So I'll start my presentation on the automated electric smart car. So the purpose is, since this is a smart car, I would like to address certain problems such as traffic, parking, and this is also an electric car. So I would like to address the high fuel prices and also just to in general to help the environment. So self-driving cars use technology to replace driver assistance with automated safety features to navigate roads. In addition, it would also help with traffic and just protect the driver in general. So the hypothesis: the smart car would be able to avoid obstacles and would perform without a driver in hand. So it would be an automated process, so the driver could just sit there and do anything, and the smart car would take care of both driving and taking care of the car. Also, the smart car has a remote control feature wherein if you want to pick something up, the driver could just use his or her phone to control the smart car. So yeah, let's go to the background research. So background research is: next generation cars will offer a more sustainable and safe transportation experience. Yes. The market segment that the smart car would most be attractive to is the moderate income individuals. This is due to because of the high fuel prices nowadays. So yeah, this is very relevant. And as fuel prices continue to soar, the market for fuel efficient small cars will increase. So if you look at it, as the prices of the fuel go, the demand for electric smart cars would also go up, since although in if you want to develop this as on a full scale, it would be very expensive compared to developing a normal fuel car, but in the long run it would really help you save, since the after how many years you will be the fuel, you won't be paying for fuel. And yeah, so yeah, let's go to materials and procedures. So first I have to for my prototype, of course, I have to gather Arduino materials. For example, the most important one are the driver module for the DC motor, ultrasonic sensors, of course, Arduino Uno, and the chassis. And so this comes in a kit, so you just have to buy it on the website. Let's see, so that's it: wheels, battery, and everything else. So first I have to build the car chassis, add motor sensor and sensors, ultrasonic, DC motor, driver, set up the wiring, build the battery pack. So what I did was I this is an example. I combined AAA batteries and connected them so that the smart car would have a higher output, and save it would have a more longer duration of operation. So yeah, I have this. So these are combined AAA batteries. So that's an example of the battery pack. Next, I coded and implemented it. So yeah, after building, so let's go to results. The electric smart car was able to perform its function. As you can see here, I blocked it to change direction, and if you look at the other picture, I am controlling it using my phone. So let's go to our conclusions. The smart car did its purpose. It changed direction when an obstacle is in front of it. It can also be controlled remotely for unmanned driving. By implementing this technology, would be able to utilize it not only for the safety of all, but also for the safety of the environment. I have to stress this enough that we as engineers have to really utilize technology to help both the safety of humankind and the environment. This is due to because that we know that there will be times when we need to save our planet, of course. So that's a relevant thing right now. Right. So let's actually look at what my code here, since it's very an interesting one. So we can just change. Right. Yeah. So I utilize library. Because it's the new ping library. This is for the ultrasonic sensor. So yeah, then software serial wires. I declared the pins for the motors. Declared pins for this for the ultrasonic sensor. This is the limit of the distance. So there will be a distance value. So next, yeah, just more setups, and yeah. Now, let's look at this. So this is for the Bluetooth one, the Bluetooth feature. So while Bluetooth is connected, I would display connected so that I would know. Now let's check. FDLRS. So forward, backward, left, right, and stop. Yeah, if you could, I would show in the demonstration later the buttons for that, and I would explain it on the way. Alright, so that's it. So if I press the forward button, I would call the move forward function, which I would go through later down below. Next is just resetting the state so that I could send more characters. Next, for the sensor, this is for the ultrasonic sensor part. So yeah, if distance is less than 20, it means that there is an object in front of the car. So for example, I'm using a Bluetooth module, but if this is the sensor, then this is object. Yeah, so there's a limit. So like there's a certain value wherein it would initiate this function. So it would stop, it would move backward, then it would stop, it would check left or right. So if it would check right first, if there is no obstacle there, it would send this distance, and then it would check left, then it would declare it the distance left. Now it would then check if the value of the distance is greater or equal to left. So it would mean that the previous distance, so it would just turn right, so and then it would stop. And likewise, if it is the reverse, turn left, then it would stop. Else, if there is no obstacle, it would just move forward. So yeah, here I was just checking the servo functions, so I commented it out. Now here's the good thing. Interesting part is this is for the servo, yeah, and this would control how the servo would look, right or left. So for example, if we go to a servo imagine servo is a semicircle, so 10 here, it would start, then it would go to 90. So yeah, just like that. Then for left, just the reverse, it would go to 180. Right, now this is the read ping. This is for the ultrasonic sensor part. Yeah, it just reads the value, the distance value. So yeah, then just the movement functions. This is for stop, setting all motors to low. This is for forward, this is for backward, this is for turn right, turn left, and that's it for the code. Alright, so I guess I should demonstrate now the product. So yeah, let's go. I would talk as this video progresses. As you can see here, there's a mess of batteries since I want this to have a higher input. Since for some reason the driver module that I have requires a higher input of battery, or maybe I'm just using old batteries. So yeah, since this was from the previous one, since I was not able to buy new batteries for right now. You can see, again, turn left, turn right, yes, turn left, sorry, check left. Right, sorry for the dog guard. So as you can see there, I'm just using my hand as an obstacle since I have limited space. But yeah, it works. So if I put my hand in front of the sensor, it will check left, and then it will check right. So let's continue. Right, so more instances. Same thing. Check left, check right. So yeah, then to the part. Now this is the part where this is the remote control part of the project. Basically, I have the sensor here. I don't know if you can see it, but yeah, right there. Then just connect. So I'll just let you look at it. So forward, backward, left, right, stop. Alright. But this time I connected it to my laptop because my batteries are running low, and I'm really not able to buy batteries right now because of financial stuff. Since chip a 9 volt battery costs 100 plus right now. So yeah. Anyway, that's it for my presentation on this automated smart car, obstacle avoidance, and then remote control. Thank you for listening, and I hope you have a good day.